Magandang araw ulit sa inyo. Welcome ulit sa Information Management class. And andito na ngayon tayo sa Module 7 at ang topic na pag-uusapan natin ngayon is yung database design. Okay? So, ano yung topic natin? Ang i-discuss natin is what is database design, database development life cycle, itatouch din natin yung database normalization. And then may part B itong topic na ito. Doon sa part B na yun, pag-uusapan natin yung tinatawag na entity relationship model. Okay? What is database design? Ito yung definition. Database design is a collection of processes that facilitates the designing, development, implementation, and maintenance of enterprise data management systems. Ayan, in enterprise data. Balik sa business, may magkakaibang sizes. Dito sa Pilipinas, according sa law, meron tinatawag na BIMBI, Barangay Micro Business Enterprise. Ito yung mga kagaya ng mga sari-sari store, mga barbershop. Ayan. So barangay micro business enterprises 'yon. Ang susunod is yung SMEs. Ayan. So actually MSME. Ayan. Micro, small, medium enterprises na business. So ito yung mga from 5 employees up to 99 employees. Ayan. So from micro 5 employees papunta sa small at saka medium, yung actually 99 part pa ng medium yun, And then, pagdating ng 100, pwede nang i-classify siya sa isang, pwede ng big enterprise ang 100 to 1,000. And then, more than 1,000, actually, hindi ko na alam yung pinaka-classification after ng 1,000, pero meron tinatawag pa na mga large enterprises. So, merong small enterprises, big enterprises, merong large enterprises. Yun. So, in this particular, itong pinag-aaralan natin is for businesses na may minimum na 100 regular employees pataas. So, tandaan, regular hindi contractual. So, binibilang lang dito yung regular. Yung contractual, additional yon sa, kumbaga, additional sa headcounts nila. So, mas malaki pa sa 100 yung actual or physical count ng nagtatrabaho para sa business na yan. Okay? So, ano yung ginagawa ng database design? It helps produce database systems that meet the requirements of the users and have high performance. So, bakit regular employees lang yung binibilang dito sa sa database design? Kasi yung binibigyan natin ng access doon sa sistema ay mga regular employees. So, it's not that usual na binibigyan natin ng access yung mga contractual, yung contractual kasi is we consider them yung sa accounting or sa business point of view, kino-consider sila na so may external kasi dun sa business, yung clients at saka suppliers. And yung contractual employees are considered as suppliers. Ang sinusupply nila is nagsusupply sila ng services para sa company. Okay? And then it helps produce a database system na mataas yung performance. Ayan. So what usually yung ginagawa ng normal na ginagawa ng database systems is ginagawang mas organized at saka pinapipilis niya yung proseso ng ating business. Ayan. So process, methods, yun yung ini-improve sa business. Okay, the main objectives of database designing. The main objective of database designing are to produce logical and physical designs of design models of the proposed database system. Okay, the logical model concentrates on the data requirements and the data to be stored independent of physical considerations. It does not concern itself with how the data will be stored or where it is to be stored physically. So, ayan, no? Logical at saka physical designs yung objective. And then the physical data design model involves the translating the logical design of the database into physical media using hardware resources and software systems such as database management systems or DBMS. So, hindi ko na ipaliwanag, self-explanatory na yung binasa natin. So, ang concentration ng database design is yung sa logical at saka physical designs. Why database design is important? Okay, database design is crucial to high-performance database systems. Apart from improving the performance, properly designated database are easy to maintain, improve data consistency, and are cost-effective in terms of disk storage space. Note that the genius of a database is in its design. Data operations using SQL is relatively simple. So, yun nga, kagaya nung nabanggit ko sa last na discussion, pag maganda yung design ng database mo, mas mabilis siyang i-maintain, mas mabilis siyang i-scale, i-update, i-upgrade. Ayan. So, pagka mahirap yang i-upgrade, mahirap yang baguhin, kumbaga, konti lang ang binago mo, babaguhin mo na yung buong system. So, that is a bad design. Pero yung good design, mabilis siya na i-upgrade or i-maintain. Okay, database development life cycle. So, yung database development life cycle ay may pagkakaiba dun sa tinatawag yung pinag-aralan natin before na SDLC, software development life cycle or system development life cycle. So, sa database development life cycle, several stages din ang fino-follow. However, sabi nga dito, steps in the development life cycle do not necessarily have to be followed religiously in a sequential manner. Ang importante lang, kumbaga, binisita natin yung stages nitong cycle na to, pero hindi kailangang magkakasunod. On small database systems, the database system development life cycle is usually very simple and does not involve a lot of steps. Ayan. So, yung pinag-aralan natin last time, mga 5 or 7 steps yata yun, yung SDLC. Pero dito sa, database development life cycle, 3 lang yung naandito, no? Requirements analysis, database designing, and then lastly, yung implementation. So, under the development analysis, nandito yung planning and system definition. Nandito rin, identify din natin ano yung resources, hindi lamang yung kung ano yung program natin, but kung ano yung hardware na gagamitin natin, at saka yung software. Kagaya nga nung sinabi ko, pagka nasa Microsoft environment ka, may sariling database kang i-consider. Pag Linux, ayun, meron ding sarili niya na DBMS. And yung sa Java or sa Oracle, ayun, may sariling server ang Oracle eh. Kung baga, you have to kailangan mag-jive yung yung pinaka implementation environment mo do sa program mo. Okay. Database design. So again, nandito yung logical model and physical model. Sa implementation naman, data conversion and loading, and then testing. So dito yung kumbaga yung mga initial data mo i-transfer mo na dun sa ating database mismo. Okay. So you have the design, physical design. Lalagyan lang kasi yung physical design yung database. So kailangan mo nang ilagay doon yung mga data mo, and then i-test kung walang nawawala at saka okay ba yung yung pagkaka-design mo. Okay, so again, requirements analysis, yung planning. This stage concerns with planning of the entire database development lifecycle. It takes into consideration the information systems strategy of the organization. Okay. And then system definition. The stage defines the scope and boundaries of the proposed database system. Isa pang i-consider dito sa requirements analysis is paano yung implementation nito within a building lang ba, a campus, or kailangan dumaan ng internet, kailangan wide area network. Kasi iba yung implementation pagka local area network lang, iba rin pagka dumadaan na ng internet. Ayan. Mas mabilis mag-implement sa local area network kasi yung physical na machine na gagamitin mo for database management ay ayun, nasa isang room lang, na mailalagay mo sa isang room lang. Samantalang yung sa wide area network, pagka halimbawa inulan sa halimbawa inilagay mo sa Santa Cruz, binaha yung room sa Santa Cruz, ay patay yung yung server mo. Okay? So may ko-consider kang mga kumbaga yung continuity plan, availability plan ng data. Ayan. Kaya yung iba umuupa na lang ng infrastructure sa cloud-based yung kanilang systems. Unlike yung sarili mo yung machines. Okay, database designing, logical model. This stage is concerned with developing a database model based on requirements. The entire design is on paper without any physical implementations or specific database management systems consideration. Okay, so ano pa lang ito yung na-analyze, kailangan mo for analysis ng pinaka data model mo. While yung physical model, ito na yung stage na database management system specific. So sabi ko nga last time, pagka MySQL ang ginamit mo, gamitin mo yung rules ng MySQL. And one of those, instead na string of characters ang gamitin mo, instead na varchar yung ginagamit pagka MySQL. Hindi ko lang memorize yung sa Postgre at saka sa Microsoft yun. Okay, samantalang sa physical, ayan, yun yung i-consider na natin. Implementation, data conversion and loading. This stage is concerned with importing and converting data from old system to the new database. So, for example, yung mga dati mong data nasa Excel lahat, so dapat yung system na gagawin mo ay may capability to transfer data from Excel papunta dun sa database mo. Kung ang normal naman is nakalagay sa tinatawag na CSV or comma separated values. Ang comma separated values kasi is text file na may may mga commas. Or sometimes hindi Excel, hindi CSV or comma separated values, but plain text, or inimbento mo lang yung yung extension ng file. Normally, yung .dat, ayun, database din yon. And then finally, yung testing. This stage is concerned with the identification of errors in the newly implemented system. It checks the database against the requirements specification. So, itong testing, alam nyo dapat kung paano gumawa ng mga testing plans. Ayan. May iba't ibang stages din yung testing, So, isa sa mga magandang i-research nyo, yung tinatawag na V-model ng testing. So, mula sa requirements definition kasi, may ginagawa mo yung requirements definition ng system mo, gumagawa ka rin ng system level na testing. Then, gagawin mo yung mga unit design, then meron ka rin unit testing, and then, ayun, ang pinaka-ilalim nun, naka-V siya eh. Meron ka ng testing plans dito, and then sa ilalim yung programming. After mo ma-program, yung ginawa mong testing plan, gagamitin mo na. Yun. Pero ginawa mo na siya during requirements analysis, design phase ng design phase ng systems development mo. Or in this case, during requirements analysis ng database development life cycle, nasa requirements analysis ka, pero hindi lang plan yung at saka the system definition yung output, pati yung acceptance test at saka system test plan na output mo na rin dito sa requirements analysis. And even dito sa logical and physical model, gumawa ka ng models pero gumawa ka rin ng testing plan. Ayun. So hindi lang yung design yung output nito, kundi yung yung test plans. Okay, so there are two types of database techniques na ito gagamitin natin pareho. Ito pagdadaanan natin. Hindi ka mamimili. Dalawang gagamitin mo. Normalization and ER modeling. So, what is normalization? Normalization is a database design technique which organizes tables in a manner that reduces redundancy and dependency of data. So, importante yung dalawang yun, Reduces redundancy. Ayan, yung paulit-ulit na data and the dependency of data. So, anong ginagawa ng normalization? It divides larger tables to smaller tables and links them using relationship. So, for example nga, meron kang application form na papel na made up of two sheets of paper tapos back-to-back pa. Ito yung mga normal na mga forms na, for example, ng government. Punta ka na lang sa BIR. Ang dami nilang forms doon, So, how would you convert that into databases, tables ng databases? So, kailangan natin gumamit ng tinatawag na normalization. So, in database normalization, we will learn database normal forms. The first normal form rules. Yung 1NF, ibig sabihin nun, first normal form, Then, what is a key? What is composite key? And then 2NF rules or second normal form rules. Then database, foreign key. What are the transitive functional dependencies? Third normal form rules or 3NF rules. And the voice code normal form or BCNF. Okay, so currently maraming normal forms may 4th, 5th, 6th. Sa pagkakaalam ko, may 7, 8, at saka 8. Ang current na pinopropose, may 9th level pa. The inventor of the relational model ng database system is si Edgar CODD, proposed the theory of normalization with the introduction of first normal form. And he continued to extend theory with second and third normal form. Later, he was joined with Raymond F. Boyce to develop the theory of the Boyce-Codd normal form. The theory of data normalization in SQL is being developed further. For example, there are discussions even on the sixth normal form. However, in most practical applications, normalization achieves its best in third normal form or 3NF. The evolution of normalization theories is illustrated above. Okay, so yung mga projects natin na gagawin under this subject is magno-normalize tayo hanggang sa third normal form. So, yan. Okay, so database normalization examples. Assume a video library maintains a database of movies rented out. Without any normalization, all information is stored in one table as shown as below. So, tingnan natin itong table na to. So, yung columns or yung pababa, like full names, physical address, movies rented, salutations, and category. Ang tawag dyan, columns, mga columns yan. And then, normally, rows ang tawag natin dun sa pahalang. Tigi-tigisa, Janet Jones, then yung physical address, movies rented, salutation category. Pero, tatawagin din natin yung, data instance. Or, actually, entity instance, yung isang row. So, instance ang isang row, tapos yung tatlong rows or kung ilan mang rows ng data yung ilagay mo, yun yung pinaka-data set. So, ang data set is collection ng instances. Pag sinabing instance naman, ito yung bawat column ay may values na. Okay, so, actually, itong table na given sa atin, tawagin natin ito na 0 and F. So, ito yung hindi pa nanonormalize na form. So, ito yung 0 and F. Okay, so pupunta na tayo dun sa first normal form or 1 and F. So, ito yung mga rules. Each table cell should contain a single value. So, tingnan natin. Dun sa 0 and F kasi, dun sa movies rented, mapapansin natin na for example, si Janet Jones, humiram siya ng dalawang movies, Pirates of the Caribbean and Clash of Titans. Si Robert Phil naman, na dalawa yung Robert Phil, pero magkaibang tao kasi magkaibang address. Isa ay taga 3rd Street 34 at saka Robert Phil taga 5th Avenue. So, si Robert Phil na taga 3rd Avenue, dalawa yung hiniram na movies, samantalang si Robert Phil ay isa lang. And, so, dati kasi uso pa yung pahiraman ng movies, Ngayon, ini-stream na lang natin sa Netflix. Okay, so, sinabi sa rule number 1, each table cell should contain single value. So, dahil yung movies rented, may dalawa sa isang humiram, dalawang movie sa isang humiram, so, paghiwalay natin yon. So, tigisang, entity instance yung kay Janet, so, magiging dalawang rows yon. Kay Robert Phil na taga 3rd Street, dalawa yung hiniram niya, so, dalawang rows din ang naka-assign sa kanya. And si Robert Phil na taga 5th Avenue, isang movie lang naman. Ayan. So, tigi-tigisang bawat cell ay single value na, hindi multi-value yung nakalagay sa isang column, kundi single value na. And then, pangalawang rule, each record needs to be unique. Okay, so, ang problema dito sa, dito sa first normal form na tinitingnan natin, isang record, ibig sabihin, isang row yun, nagre-repeat yung, name at saka yung address. So, dalawa na ngayon yung Janet Jones, dalawa yung Robert Phil na taga 3rd Street. Okay? So, kailangan may paghiwalayin tayo. So, it's better na yung full name at saka physical address, which is medyo related, at saka yung salutation ay kumbaga nandun yung dependency, So, yung physical address is dependent on the full name, and yung salutation dumidepende din sa full name. So, masasabi natin yung physical address sa salutation is dependent on the full name. Pero yung movies rented, hindi naman siya dependent. So, pwede nating ihiwalay yung walang dependency. Ayan. So, pupunta na tayo sa So, magiging dalawa na yung tables natin, Isang table na naglalaman ng full names, physical address, at saka salutation. And meron tayong panibagong table na puro movies lang yung nakalagay. Movies rented. Okay, punta na tayo sa second normal form. Ano ba yung rules? Rule number 1 ng 2NF, kailangan yung mga tables mo are in the first normal form. Okay, so makikita natin, first normal form na siya kasi dalawang tables na. Pero ano yung nakalagay sa rule number 2, dapat merong primary key ang bawat may column na tinatawag na primary key. Ayan. So, yung natin, yung mga nanghihiram ng movies, nilagyan natin ng membership ID. Yun yung primary key ng members or nitong persons with full names, physical address, at saka salutation. And then, yung mga hiniram na movies, yung movies rented, nilagyan din natin ng primary key. Actually, kailangan kong i-correct pala to, Ayan, i-correct ko. Dagdagan ko ng dapat merong sariling may sariling key, primary key itong movies rented. Hindi pwedeng membership ID yung ginamit niya kasi foreign key yun. Okay? So, ano ba yung tinatawag na key? I-define natin. A key is a value used to identify a record in a table uniquely. So, dapat isang key, yung mag-follow na data sa kanya is dapat unique dun sa record na yan. A key could be a single column or a combination of multiple columns. Okay. So, note columns in the table that are not used to identify a record uniquely are called non-key columns. So, pwedeng magkaroon ka ng iba't ibang keys, Pero itong susunod na i-discuss natin yung primary key. A primary key is a single column value used to identify a record uniquely. So, ito yung characteristics or attributes ng isang primary key, Pagka yung key ay hindi null, must be unique. So, hindi masyadong binabago yung key value na yon. Tapos yung key ay binibigay ng value pagka may bagong record, ang tawag doon is primary key. Okay? So, hindi pwedeng maging primary key na binibreak niya itong mga attributes na ito. Pagka halimbawa, yung nag-add ng bagong row or instance ng isang entity or ng isang table, so pag pwedeng null yung key na yon, hindi siya pwedeng primary key. It cannot be a null. At saka kailangan may value siya pagka nag-insert nga ng bagong record. Okay? So, gaya nga nung napag-usapan natin kanina, yung mga borrowers, firstly, it is, yung pwedeng mag-identify sa isang row ay yung first name, yung full name, Pero yung full name, minsan nagkakapareho yung full name. That's why kailangan natin yung panibagong identifier, which is saan siya nakatira. Nakita nga natin, dalawa yung Robert Phil, pero magkaiba yung addresses, therefore, magkaibang tao siya. So, parehong pwedeng maging key identifier natin yung full name at saka yung address, pero hindi pwedeng magkahiwalay kasi pwedeng pareho ng address pero magkaiba naman yung full names. Okay? So, ibig sabihin, may dalawa tayong candidate key na pag pinagsama natin, pwede niyang i-identify yung buong row. Ayan. So, ang tawag doon, pagka more than one yung key na identifying key doon sa isang row, ang tawag doon composite kasi more than one na. So, pag isang column lang, so key lang yun. Pag two or more na keys na kailangang i-combine, composite key na. So, a composite key is a primary key composed of multiple columns. Okay? So, ang composite key pwedeng primary key. In our database, we have two people with the same name but they live in different places. Ayan. So, composite key, kailangan two or more keys na kailangang i-combine para mag-create ng primary key. Okay, so sabi ko kanina, yung membership ID na tinignan natin kanina, hindi siya primary key. Unang-una, hindi siya unique kasi dalawa yung 1, dalawa yung 2s, so hindi siya unique. So, at saka saan nanggaling yung membership ID? Nanggaling siya dun sa mga members ng ID siya ng mga members. So, foreign key actually siya. Okay? Ayan. It is also a key pero hindi siya primary key. Dahil nilalabag niya yung yung uniqueness ng isang primary key. So, kailangan dagdagan natin to ng primary key, itong pangalawang table. Okay? So, a foreign key references the primary key of another table. It helps connect your tables or it helps relate your tables. A foreign key can have different name from its primary key. Pero para hindi nakakaligaw, better na yung primary key na pinanggalingan ng foreign key mo, yun din yung pangalan dun sa foreign key. It ensures rows in the table It ensures rows in one table have corresponding rows in another. Unlike the primary key, they do not have to be unique. Most often, they aren't. Ayan. So, hindi siya unique. Pwede siya mag-repeat. Foreign keys can be null even though primary keys cannot. Ayan. So, pero mahirap yung null na foreign key. Ibig sabihin, may nangyayaring orphan, may nauulila na row. So, nawala yung nawawala yung value. Dapat kasi as much as possible may related siya sa main table. Okay, so why do you need a foreign key? Suppose a novice inserts a record in table B, yung sa table number 2, such as you will only be able to insert values into your foreign key that exists in the unique key in the parent table. This helps in referential integrity. Ayan. So, referential integrity, so, ibig sabihin, pagka hinanap mo yung nakalagay sa second table, hinanap mo siya sa first table, so dapat meron siyang reference doon. Pag nawala ng reference, hindi na mabibreak yung rule ng referential integrity, meaning nga may na-orphan, may naulila na entity instance. Okay? Ayan, so ito yung example, insert a record in table 2 where member ID is 101. So, 101. Pag pumunta ka dun sa members table, wala namang 101. So, ibig sabihin, may nanghiram na doesn't exist. So, error yon. So, pagka gumawa ka ng system, kailangan i-issue mo yung error. So, that will help referential integrity. Yung, kumbaga, yung member na yon doesn't exist. Okay. Transitive functional dependencies. Ito pinag-usapan na natin kanina. A transitive functional dependency is when changing a non-key column might cause any of the other non-key columns to change. Ayan. So, may dependency ang isang column to the other na pag binago mo yung isang column, for example, in this example, binago mo yung full name. So, hindi na pala siya lalaki, naging babae na. So, mababago yung salutation. Sex change, kunyari si Robert Phil na taga 5th Avenue. So, from Mr. magiging Miss. Okay. Or si Robert Phil, nagpapalit, yung asawa na niya, yung manghihiram, hindi na siya. So, yung salutation, mababago din. So, yun, may dependency, transitive functional dependency, si salutation kay full name. Okay, third normal form naman tayo. Ano yung rules? Rule number 1, pwedeng maging third normal form lang yung tables mo kung at least nasa second normal form siya. And then has no transitive functional dependencies. To move our second normal form table into third normal form, we again need to divide our table. So kanina, pinakita natin na yung salutation na column ay may transitive functional dependency sa full name. So paano tatanggalin yon? Ayun, magkakaroon tayo ngayon ng third na column. Okay, so instead na ilagay natin yung salutation sa members table or yung table number 1, nilagyan na lang natin ng salutation ID. Ayan. So, magkakaroon tayo ng table for salutations. Nakalagay, Mr., Miss, Mrs., Doctor, etc. Ayun. Okay, so, ang susunod sa third normal form is yung BCNF or Boy's Code normal form. Okay, even when a database is in third normal form, still there will be anomalies resulted if it has more than one candidate key. So, yung BCNF daw ang tawag ay 3.5 normal form. Hindi third normal form, kundi 3.5 normal form or actually BCNF. One candidate key. Okay, so more than one candidate key. Yung fourth normal form naman, so wala na tayo example pala dito, dahil hindi naman natin gagamitin. Fourth normal form, dapat naka third normal form at least. If no database table instance contain two or more independent and multi-value data described in the relevant entity, then it is in fourth normal form. Okay. Sa 5NF, ang sabi dito, a table is in fifth normal form or 5NF. If it is fourth normal form, it is in fourth normal form and it cannot be decomposed into any number of smaller tables without loss of data. Ayan. So, ang sinasabi dito, yung bawat tables natin, dapat ay hindi siya pwedeng paliitin pa, Pagka pinaliit pa natin, may mawawalang data. Ayan. Pag na-ensure natin yon, fifth normal form na daw ang tawag doon. Yung proposed na sixth normal form, so hindi pa siya standardized. So, dinidiscuss pa. So, ayan. Hindi rin diniscuss dito. Okay, that's all to normalization. Okay, so next pag-uusapan natin yung entity relationship na modeling. And to summarize itong ating topic na ito, so database design is critical to the successful implementation of a database management system that meets the data requirements of an enterprise system. Normalization helps produce database systems that are cost-effective and have better security models. Ayun guys, ang cost kasi ng development, actually maliit lang yan sa compared sa cost ng maintenance. Ang sinasabi nga, ang cost ng development, halimbawa 1 million ang cost ng software development ng dinidevelop mong software system, information system, 1 million. So, i-times 5 natin yon kasi nga 20%, 10 to 20%. I-times 5 natin yon. So, nasa 5 million yung maintenance or additional 4 million. Or kung 10%, 10 to 20% naman. So, kung 10% naman yung ating tinitingnan na development cost, yung 1 million, so, ang maintenance niya is 9 million. So, mas mahal. Functional dependencies are very important component of the normalized data process. Ayan. So, yung normalization kasi, pagka hindi mo ni-normalize yung database mo, dun mangyayari na pag minodify mo ang structure ng database mo, ay magre-redo ka ng buong system. So, kung mahirap i-maintain, doon lumalabas yung mahirap i-maintain at mahirap i-scale or gumawa ng mas bagong sistema kaysa doon sa ginawa mo. Ayun. So, kailangan natin ni-normalize ang database natin sa isang information system software. So, most database systems are normalized database to the third normal form. Okay? So, 3 and F, okay na. A primary key uniquely identifies a record in a table and cannot be null. A foreign key helps connect tables and references a primary key. Ayan. Okay. Konti lang example nito, pero gagawa ko ng video na or discussion regarding paano ba mag-normalize ng isang database. So, please view that. Yung practical nito, later na lang natin, or yung activity na gagawin nyo talaga yung normalization, next na lang natin i-discuss. Ang importante dito is i-take note nyo yung mga definitions at saka mga phrases and terms na nakalagay. Okay, with that, thank you and antayin natin yung susunod na discussion. Thank you.